Okay, if we think back to the compound interest formula, we had the continuous compound interest formula, which was this, okay? The amount, future amount, is the initial amount, your principal, E, with the interest rate and the time, okay? Now I'm going to do just a general formula that also applies to things like exponential growth rate or even exponential decay. Okay, so like population growth, bacteria growth, radioactive decay, and it's this. The future amount is the starting amount, E to the kt. And of course, it's very similar. It really is just the same as these are the same things. It's just that this is in terms of money with the interest rate. This is just an initial amount, and this is the growth rate. I mean, it's basically the same thing. But again, remember, this is the initial amount. So if we look at something like this here, question 53, if I was to actually write this, just trying to find a function for this, then really all I'm trying to find is, okay, what's the initial amount? Okay, maybe what's the growth rate? So I would have this, okay? So again, my future amount is going to be the initial amount with E, and what is the growth rate? Write that as 0.11, excuse the dog, 9, and again, T, okay? And that's all it's looking for, T. That's all it wants. Okay, so let's have a look at a bit more, let's say, complicated questions. Let's have a look at question 56, because these are kind of heavy on the test as well. 2001, first brain transplant. 2010, the first brain transplant, the only transplant performed that year. Right, I guess that's what. Okay, so what this is looking at is there was one brain transplant, okay, in 2001. So there's 741 in 2010. So here we go. The future amount of brain transplants was that. The initial amount was that. And E, okay, it took 9 years, but I don't know what the growth rate is, okay? So let's take a look at that, okay? Okay, so we do know the future amount in 2010. We do know the initial amount in 2001. And we do know, of course, that took 9 years, from 2001 to 2010. Okay, so we have to try and find out what the growth rate is. So what I'm going to do is okay, now, it's kind of nice, it's a 1, but you always need to get rid of this. Always need to get rid of this first, and that's usually divide by the number next letter. So I'm going to divide both sides by 1. Now, of course, that's going to make a blind bit of difference, okay? But I'll now have this. I'll just write that as 9k up there, okay? 9k. Right, so I don't really need that one there. Let's not bother, okay? Now then, here is where that important rule comes in about how do I find the unknown exponent? You log both sides. Now, I am going to use ln, and the reason is this here has a base of E, so ln will work great, okay? So there we go. There, I just logged both sides, but I used ln. And the reason for this is very important. Look at this. You are going to be using, remember this rule? Log to base b of b to any exponent is just the exponent. Now this is base E, so because those two are the same, the answer is just 9k. I've got this, if I find some space, down here. I've got ln of 741 equals just the 9k. So always remember, if you're going to log something with an E, the answer is going to be just the exponent. Okay, so if you divide both sides by 9, that's the, whatever that is, folks, I'll put it in your calculator, and that's the answer. That's what the growth rate is, log of 741 divided by 9. So that's it. So let's try and apply these. See if it applies to any other questions on here. Okay, how long will it take? Okay, let's look at this one. Now then, how long will it take for a population to double? Okay, so right now we've got this. We have the future amount, we've got the starting amount, we've got good old E, we've got the growth rate at 0.027, and we don't know what T is, okay? Now then, here's the trick about doubling time, okay? If this, whatever this is, if this is twice the amount, so here we go. Supposing I started with a population of 50. If I double it, I'm going to end up with a population of 100. Okay, so even if I do this, I'll just do this. Was it 270 again? Okay. So if I divide both sides by 50, can you see I'm going to end up with 2. The doubling time just means this. 2 equals, there you go. Because no matter what that is, if I double it, I'll always end up with 2 on the left-hand side. So that's why there's no initial, in this question here, there's no initial and future amounts like this question had, because double means just write 2 on the left-hand side. Now I'm going to, again, I'm going to log both sides. Here we go, ln, because guess what happens over here? All you get is the exponent. Because remember, that is base e. So down here, I'm going to write this. I'm going to write this. So if you divide both sides by the number next to the letter, and put that in your calculator, no idea what you get, be careful, okay? Who knows what it might be? 30 years, 40 years, 50 years, something that makes sense, okay?